Good morning. Thank you for everyone attending today, this webinar series. My name is BJ Kowalski, and this is a webinar on digital dentures, today's solutions for edentulous patients. So just a little bit about me. Rowe Dental Labs, a full service lab, been around for pushing 100 years. We have 195 great team members. Unfortunately, like all of you, they are not working currently. Rowe is still open and operational with a very limited team at this point. But we're still open and operational, making cases for emergency patients and finishing up some work, and certainly here to consult with our clients on anything they need. We do have a lot of people working from home right now, remote, so we did a really great job of moving people off-site and social distancing. So this lecture about digital dentures is as much about change as it is anything else. Dentures have not changed very much in the last 100 years. In the 1900s, the 19th century rather, we had vulcanite dentures. In the 20th century, acrylic became introduced, and that became the mainstay of this material. But now in the 21st century, I firmly believe 3D printed dentures will take the main stage, and this will be the main method for producing dentures for a lot of reasons that I'll explain to you today. But when I think about change, one person comes into mind in one event that I think really epitomizes change out there, and it's this gentleman. And I don't know if any of you know who he is, but his name was Dick Fosbury. In Olympics high jump event, people used to jump over the high jump like this gentleman here. And everyone did that from the beginning of the Olympics since this sport started. But in 1968 Olympics, Dick Fosbury, who had changed the high jump technique a little bit before this and a few other events, came into the Olympics and won the gold medal, and his teammate won the silver medal with something called the Fosbury flop. And from that point on, almost every Olympic athlete that competed in this event in the world stage used the Fosbury flop technique. So just like that, on the main stage, he was able to change the sport forever and how it was done. And I think that kind of event is what's happening with digital dentures right now. And we are at the turning point where it is a better method to go for production of dentures, not only for your patients, but for yourselves and time savings, for the labs, trying to deal with a pool of decreasing denture technicians. There's a lot of great advantages to this. So like the Fosbury flop, 3D printed dentures has found its time, just like the 1968 Olympics. So our journey with digital dentures is not new. This is part of the Chrome Guided Smile webinar series, and we really started with the Chrome series. When we needed a backup denture, we had these digital files. As many of you saw those lectures earlier in the week, we had the backup files from the immediate load prosthetic, so we decided to use those files in making a printed denture. They weren't often used because they were just in case dentures, just in case the case couldn't be loaded. But nonetheless, we had great success with them. So then we moved on to using it for hybrid dentures, fully milled prosthetics. So one piece milled, teeth and base, all milled in one, and had some good success with that. And then we moved it to immediate dentures, economy dentures, and now we're in the position with the increase in advent of new materials to move this into the realm of taking over conventional dentures. So like I said, we had so much success with full arch guided surgery, and thinking to myself, geez, if we could take a patient with bone reduction, tooth extraction, and get those teeth right on the money time and time again, why couldn't we do this with our regular denture cases? And that's exactly what we've done. So what are we going to talk about today? I think we're going to talk about some really cool stuff. We're going to talk about digital dentures, printed dentures, the new materials that are available. We're going to talk about how you can duplicate a denture. A patient comes in from just scanning techniques in your office. We're going to talk about how you can make a denture from just using your CBCT in your office and never even taking an impression. We're going to talk about something that we invented here called the floating teeth technology, which is a hybrid technology between it. So no further ado, I'll jump right into it. So dentures for a long time have been based upon manpower and materials. How many doctors out there, have you heard somebody say, I have a great denture guy? It was always about the guy who would do the denture work for the clinician and his talent and his skill. And that's how it went and continues to go in some degree for a long time. And then it became about materials. Oh, Lucitone 199, it's a stronger material. I'm going to use that material. Or Ivocap material. I'm going to use that material. And then it moved over into machines with Ivocap processing, a pressure injected process for injecting dentures. It was a better technique. So not only who set up the teeth, what material you use, but how you process that material. And now there's another player in it with software. And the software is really what, in my mind, takes this technology and to us it says this is a better direction to go with dentures, because the software is so intuitive and it just makes the right decisions all the time for you and your patient to get these teeth in the right place. So why digital dentures? So I'll give you some convincing of why I think digital dentures are the way to go right now, and we'll expand on the technology a little bit later. So why digital dentures? Faster completion time. If we need to do a rush case, a quick case, we literally could do a denture complete in a few hours with this technology. It's amazing how fast that we can make these bases, print these teeth, and assemble these things. So before we had stone setting time, we had processing time, we had acrylic processing time, lots of things we had to wait for. We don't have to wait for too much anymore. We can print teeth, print the base, print teeth, insert teeth all at one time, very quick. One of the biggest advantages for all of you is less appointments. And I'll explain this later, but in many cases, we are suggesting to skip the setup phase. With these technology that we have today, the positioning of the teeth and how we do it, and I'll explain how, is so much more accurate than what we had before that we're able to skip appointments, less resets or no resets, and also lower cost. This technology is lower cost. Our digital dentures are less expensive than our conventional dentures, and we can pass that cost over to you. And let's face it, a lot of our clients do a premium job, and they work with patients that want the best possible denture they can. But in the United States of America and in the world, dentures are an economy prosthetic. I mean, most people have dentures because they didn't have money to take care of their teeth for a lot of their lives, and they need an inexpensive denture. We can do inexpensive dentures with this technology, and you can be profitable, the lab can be profitable, and the patient can have a great product that's superior to some cheap denture made offshore or with not a little attention to detail because they had to get it done quickly using conventional methods, and the only way to do it quickly was to not care as much about the case. So we can definitely lower the cost, and we'll explain in detail costs. Every time we do a digital denture, we have that record. At any point, someone can say, give me another one of those. We can produce exactly what we did before and give it right back to you. So almost any fully edentulous case, it's a good candidate for. Digital partial dentures is still, I think that method, at least for the next 12 months, will be done conventionally. Though we can do the teeth, it makes a lot of sense to do conventional partial dentures with setting wax at this point. I think they're attractive. They're very nice looking cases. We can characterize and do things to them. I think that you can make a conventional denture look slightly better than a digital denture, but again, this is all in the creativity of the person doing the work. And they're strong, and that's the big factor. The initial 2 years ago, there was a strength issue with digital dentures, so we use them for economy and more significantly immediate load backup denture. They're only going to be temporary. Now, today, with changing technology and materials, they are strong enough, and we'll talk more about that. So how is it better? And bottom line, it's a computer software that makes it better. Just like an architect uses a computer instead of a drafting board, we still need people that know dental technology. We still need people that know how teeth should be and have some artistic flair to it. But a lot of the monotonous work of getting the teeth positioned are all taken care of with the software. We can set teeth much quicker. We can balance them much better. And it's using the landmarks of the patient to position those teeth ideally. We, for a long time, Rowe was an advocate of Staub cranial dentures, which it was a method based on Karl-Heinz Staub that basically took anatomical landmarks and allowed us to position teeth in an arch just from the anatomical landmarks on the model and give the doctor back a setup right from initial bite records. We had or we actually would do a upper setup with a lower bite record was our go-to situation with these. And we had a lot of good success, and we were raving fans of this technique because it used science to position teeth as opposed to a technician opinion. Well, it's funny that with the technology now, with 3Shape's denture module, which by far is the best denture module on the market. There's other systems, exocad, Blue Sky Bio, there's other things, Avident. We feel their technology is way better than anyone else's, but it basically uses anatomical landmarks to determine where the teeth should go, just like the success we had 10 years ago with this mathematical calculations we made. So in fact, we're having so much success with digital dentures that this is the protocol we're using now is the Dentsply Carbon, which we feel is the best system to go with. They recommend a printed try-in of these cases. We can do that, but in our experience, doing thousands of digital dentures at this point, we kind of are sitting back and saying, gosh, so many of these cases have come back from the try-in and doctors say, finish them, go to finish, everything's perfect. We've done thousands of these cases on guided surgery cases where the teeth are in the right position, that we're suggesting at this point, why do the try-in? Why take up your time? Why take up the patient's time? So we're recommending at this point, skipping the try-in phase and not having a try-in. Give us great preliminary impressions, spend a lot of time at the bite record, not too much more time than you normally spend, but we definitely want a picture, which I'll explain, and make some markings and really think about the bite record, and we go right to finish. And if it doesn't work out, we have a great solution for that we call a reverse reset that I'll explain. So that's right, what I'm suggesting is take impressions, take a great bite rim with a picture, with the bite rim in place, with markings of midline, in your opinion, high smile line, angle of the cuspids. You can use a Sharpie, you can use a wax knife, and then we send you a finished case back. So what does this do for you? Number one, it lowers the lab cost. Digital technology, digital printed dentures lowers the lab cost anyways. It also saves money with reducing resets, and it saves the patient money and gas money and time off of away from work. Less resets or no resets, and less appointments. So this typically can be done in 3 or 2 appointments, depending on if you do the bite rims in your office or not. And we're having great success with this with lots of cases. So instead of leaving it to the end, let me talk cost. So we break our digital dentures down in 2 types. A standard low impact base, which is a different 3D printed material, and a premium high impact base, which is stronger. We highly advocate the stronger material. It is significantly stronger, which we'll talk about a little bit later in the presentation. And then we have options with teeth. Do you want standard printed teeth? Do you want premium printed teeth or premium carded teeth? Carded teeth meaning tooth cabinet teeth that you have come to expect. Printed teeth are one solid piece of teeth that fit into the base that we'll explain. And if you have to do a reset, we'd have a reset fee called a reverse reset that we'll explain. But for a final denture, this is what we advocate. But for an economy denture, an immediate denture, $149. That's the cheapest price we've offered a denture in 30 years, 40 years for this prosthetic. So it's a great fee for immediate economy cases, premium cases, reverse reset, which we'll explain what that is, and then the floating teeth technology we'll talk about later in the lecture. And that's it. That's the basic price point with these prosthetics. So what's a reverse reset, you might ask? So if a reset is needed, have so many cases come back accurate, we decided we're going to suggest, and we don't have to, we'll do a try-in, no problem, but we'll send you the finished prosthetic back. If for some reason it doesn't work and you want it changed, you want to change the bite, your teeth position is not to your satisfaction, which we doubt that the teeth position is going to be a problem at all because we're going to get photos with these cases. We will basically take your records in, completely redo the setup, which we're just opening it up and remodifying it, and print you another denture and send you another final denture back. And if the first one's good enough to do, to keep for something, then the patient has a backup denture. So for $49, we call it a reverse reset. We remake the prosthetic after the fact with any changes needed, with the hope that in the vast majority of cases, you're not going to need that, and you just have the lower fee of the, so that's where we get the savings in here, is we are not basically doing a reset phase, and we're skipping that whole process of getting a case back and forth. So if a doctor might be listening in the audience that says, hey, I love doing try-ins, I want to adjust the teeth myself, we can do that. We can do something called a floating try-in that I have a nice slide series on. So like I said, it's super important that we get pictures when we get these cases. Pictures like you see here, we want to have the patient smiling. If they have natural dentition with their immediate case with their teeth in. If they have a bite block, we want to have it with the bite block in. So as you can see, when we're setting these cases up, this is an immediate case. We provide the teeth. We do the digital setup is done here. We're placing we're setting up this case within the patient's face, and that's so critical to why this is working so well. And then we get back a great final restoration. So when you're sending pictures of the bite block for a normal edentulous case, an edentulous protocol, this would kind of be what you would send. We want to get this picture, bite block in place. In this case, maybe this wax up needed to be carved back some and reduced so that it was maybe catching the patient's lip in the intervermilion border there slightly, but get this bite block, carve it back, get it right where you want it, put your markings in there, and right from that information, we bring it into our digital setup and we're setting this case within the patient's face. Gone are the days where someone is looking at a picture, a recent picture or one from 30 years ago of the patient's teeth, and then looking at an articulator with no spatial relationship of the face to that picture of setting up the case. We can set teeth within the patient's face, and that's what we do every day with these cases. So here's a bite rim with nice markings on it, gives us nice indications. The doctor spent some time getting the vertical dimension closed. We make some markings to basically take the scan models of the edentulous arches that we received and the bite blocks that are scanned in our system, and we orient those with this bite block. So as you can see, that was the same bite block you saw in wax. Now it's digital. Now it's in the patient's face, digital, and the patient's face is in the articulator. So then at that point, we're starting to set the case. You can see, how are we going to get this midline off? I mean, if you've marked that midline where you want it, I mean, we literally have to ignore the information to do it. Before it was more difficult. There was canting of the teeth. I mean, if we are setting this case and the neck of his teeth is protruding in the patient's lip, we're going to see it coming in the software that is, protruding out of the patient's lip because we're orienting it to the bite rim, to the flat plane of the bite rim. So positioning these teeth within the patient's smile is a huge advantage for getting these teeth in the right direction. And the main reason why I'm so excited about this technology and why it's worked on literally thousands of cases for us over the last couple of years. And then we go through our normal setup process and we set the lower, all the process is the same. The setup process takes about half hour in the computer per arch to set these cases. So we have great technology. The software has taken us to places we couldn't get to before on an articulator. And now it becomes, we have a great design. We have a CAD file that we want to do. What are we going to print it with? So we're not new to the game of 3D printing. We've been printing things on 3D printers for almost 15 years. We started our first 3D printer, was about as big as a small Volkswagen. It printed little wax copings that we would wax and invest in cast. But unfortunately, for every case that we designed, we threw away. If we had 50 copings, we'd use 5 of them and throw the rest in the trash because they didn't work very well. And then one day I was at a Chicago Lab Day meeting and there was a guy sitting at the table from 3Shape and he was alone by himself. No one was talking with him. He hardly spoke English. And I attempted to buy their scanner, to try something different to see if we can get this to work, because everyone was making fun of us because we had this 3D printing technology and it was good for nothing. I like to say it printed really bad wax copings. And we got the printer after trying to figure out how to get it imported in the United States because it didn't have a distribution channel set up. And all of a sudden, those wax copings started to fit better. We only threw away half of them. And from there, that started our digital denture journey and improving printers. And instead of sizes of Volkswagen, they can fit on a desktop now. So with digital dentures, I did a study a while ago in a presentation at the Digital Dentures Symposium for IDT, dentist and lab technician meeting. And I had all these, we had all these printers in our facility, and we have most of these now, and we did tests on multiple patients doing the case multiple times with all the different systems. And I neglected to mention that if anyone has questions during this presentation, please, in the comments section, there's a chat feature. If you want to put your notes in chat and ask your question, we can answer them at the end. I'm going to try to end promptly on time, but I can stick around as long as possible. With ChatFeeper, or anyone wants additional information on anything, or give me some more facts on this, or show me that study, I'm happy to email it over to you after the presentation if you add that into chat. So we've worked with all these printers for digital dentures and more, and they all work in very much the same way. In my study, this is the NextDent machine, a Colzer machine, the Denka that uses a carbon resin, which is now they're using a resin from Dentsply now, and Invisitech. They all can do a good job. They're all made to make crowns. So think of the tolerances that we can do on crown and bridge restorations. The tolerances don't nearly need to be as good on removable prosthetics, although the fit of the teeth to the base are important. But it basically goes into this vat of liquid and cures the resin. And then they come out and they all have these different light boxes that cure it at a specific light wave. And they all made different prosthetics. I find the difference is more in the opacity and the translucency of the acrylic, but the real difference came down to strength. Some of these dentures and some of the materials were a little bit brittle and broke a little bit. And we frankly, if we dropped one on the floor and it broke, that was not a good sign for us, because we can't have a patient, you can have your patients dropping a denture in the bathroom and having it break. That makes us look bad and you look bad. So we just used it as a economy, really more of an immediate load, real temporary, only for a few week kind of situation, or rush cases. And that's how we started out with this journey, but it did a good job. But through all the dust have settled, and I think it'll change in time, but clearly the winner in this technology right now is the Carbon Dentsply partnership. Carbon is a company that makes 3D printers. They do some amazing things, which I'll show you their technology. And they partnered with Dentsply Sirona for several years, developing a resin that worked in their system that was as strong as the Lucitone 199 acrylic. So we can print 8 of these bases in 2 hours in their equipment, and then print the teeth in a shorter amount of time. The 3D printing technology and how the resin's made is completely different than acrylic, and has a lot of advantage. And I think it's going to continue to improve, and structurally, right now it's as strong as Lucitone 199, but I believe in the future it's going to be exponentially better and stronger than acrylic materials, because they can develop this material on a very small nanoparticle level, and really have material science is spending a lot of time and money with 3D printing. And this is the way of the future for a lot of technologies. But we have libraries. We use the Dentsply Sirona library for this. We also have Ivoclear libraries and Colzer libraries in our software. No grinding is required, and it has exceptional wear. So how does the printer work? So this is basically how this printer works. It's a platform at the top, and the bottom is a window that allows oxygen permeable layer. We have a vat of liquid. Literally, it's like it seems like the viscosity is much less than regular acrylic, but it's a liquid pink material, or white if we're doing the teeth. And how the printer works is that the UV light goes through. We in the nesting software, we attach supports, we attach the prosthetic, and it goes in and it cures the resin. And what's important here is they have a unique patented technology on this, which is called the clip technology, that allows this printer not to stop when it's printing. It keeps printing, and there is no oxygen permeable layer on it. It uses DLS digital light synthesis technology to cure this, and it cures it faster than any other technology on the market. This is the fastest printer on the market, and it's also more accurate. This is a little video showing how it works. This is time-lapse and improved in speed. But 3D printing, there's several different kinds. It started out with stereolithography, and then technology came out with MSLA, which was liquid crystal mass stereolithography. There's also SLS, which is laser sintering, which we use for all our digital partials, which are phenomenal. So all our partials are laser cured in a very similar manner, but with metal particles. So as you can see, that's just growing out of the vat of resin. And that's very similar to how the dentures are made. And it's only going to get faster materials are going to get better, and the processes are going to get faster. So our carbon printers run pretty much nonstop, 24 hours a day, when we're busy. So before we have the files, we have to nest them. We create this little lattice work structure underneath it. So that, and we put that right on the border, and it snaps off and does not affect the shape of the border at all. And you can see right here, as it's finished printing, we just break these off after it's cured. And I make fun of the folks in the printing room that when they're cleaning these off, I can't believe you get paid for this. It's like one of those very enjoyable things, is to break these little pieces off like stepping on bubble paper. So it's very enjoyable to do, but they go through a cleaning process with isopropyl alcohol and vibrating it, and it creates all these sockets for individual teeth that we place in there. At that point, we place in the Dentsply teeth at this point. Place them right into the sockets. They fit securely. There's no wiggle room. It fits exacting. There's small gaps that we use to basically glue them into place. They're put into place with the same resin that's made out of the prosthetic. And we also have the option of printing the teeth all in one with their Tri-In material, which is another option that works great. There's nothing to debond, there's nothing to come off, but that's the basic process of how 3D printers work. We cut off these little tabs. As you can see with 3D printing, the material is always uniform in thickness. There's never a thin area. You don't have to worry about anybody finishing an area down, making it thin. The name is actually printed in here in 3D printing, and we take some ink and we rub it over it so it has a slight darker tint to it. So the name is actually 3D printed and embossed into it as well. But it's a fantastic technology that we're working with. So comparing this material and why it is stronger, Dentsply will say this is as strong as their Lucitone 199 material. It was original Lucitone that came out, and then they came out with a Lucitone high impact acrylic, which has slightly less flexural strength, but slightly higher flexural modulus, which is more important for a denture. And this material is right on par with their other materials that they have, that they've had and have been proven, have been really the mainstay of dentistry in the United States for many years. For 30 years, that's been a go-to material for acrylic, and this material is just as strong as it. But what they have found, because of the technology is different than acrylic, they found something called a BAM effect, and they did not know this till after the fact. But they found that once this material has been placed in the mouth and subjected to body temperature, it has amplified its properties and significantly increased its strength and resistance to breakage, and even prevented it from cracking. So this material, they're finding, is becomes stronger once it's in the mouth, and significantly stronger. And there's a study, I'm not really supposed to talk about it too much, but there's a study that has been going on for several years at the University of Boston, both in vivo and in vitro study with multiple patients, and it's going to be released very soon. I tried to get that study, but it hasn't been published yet. It's all been written and finished, but it's going to be a big deal for Dentsply Sirona, because I believe they're going to prove in there that this is actually much stronger than regular dentures, and this BAM effect is going to be verified with the clinical studies, I believe. So this technology is impressive. I just want to talk a little bit about 3D printing technology and carbon for a minute. I'm going to play this quick video. So this is a video about football helmets. So Carbon is not in dental. They're not a dental company. They make all kind of parts for the medical space, all kind of different space. In fact, I have a pair of Carbon shoes on right now, where the Adidas has hundreds of these printers printing customized carbon soles for them. But what they're doing in football, they really feel this is going to be the answer for concussions. So if you notice on the left-hand side with this lattice work, it is so detailed, and it can be customized for every possible patient. So if you have a lineman, they take a different kind of impact on the line at slower speeds than a receiver would from a defensive back. So they change these grids on it. They change the thickness of them. They change the position of them, the intensity of them. For different athletes, depending on what kind of impact they have. And they completely redesigned a football helmet that is designed for each individual patient, each individual athlete, and the position they're playing. This is the kind of thing you can't do with extruding acrylic or milling something. This can only be done with 3D printed technology. For example, Roe, I mean, we're in, this is a bad time, in dentistry, probably the worst in all of our lives. And our workflow, even though we're still open, has gone down to a trickle. So I'm trying to be creative, keeping our people busy. We've actually, we're creating several products with 3D printing right now, and going to be marketing them to help the cause, to keep our people busy. These are swabs. They're about 10 inches long, and they have a very detailed tip on them, much like this, that can go into a patient's nose to test for COVID-19. They're about 10 inches long, and the geometry of it is such that it can grab the mucus in that area, pull it down so they can be analyzed. With our 3D printing capacity we have, we're going to be able to print 20,000 of these a day. And we're going to begin probably next week, as soon as we get some final FDA approval from it. So it's FDA approved material, FDA approved technique, University of North Carolina design that they're giving out to people. We're also printing head shields. Why? Because they're in need, and we can have them. We have the capacity. So we can knock out at this point with a partner that we have, looking at 800 face head shields a day we're trying to produce. So my point is, this isn't a dental product. This isn't dental technology. This is amazing technology for humankind to change how things are done, and dentures are the recipient of this technology, and they're going to help make dentures better as every other product they make improves. So here's a funny video. One of our guys, great guys, Fred, did a little video. We have all kind of videos on Instagram and Facebook with all these little things, but in here, Fred was explaining the denture and how it works, and how strong it is, and he makes a little joke because we have Will Smith and one of these Instagram things. He's throwing it down the hallway. Just, of course, it's not a real case. It was a duplicate of a case, but showing that these things don't break. You can throw them, you can step on them. You have videos of running them, having them run over by cars. In fact, one of our customers, she calls herself the denture queen, out of Dayton. She had an example 2 years ago where she dropped, Valerie McMillan, dropped the dentures out of a third-story condo, and they broke on the ground. 3 years later, with this material, she did the same thing with carbon, and it did not break. So it was a really fantastic example of how the technology has improved. So the floating teeth technology is something that we came up with and thought it would be a great idea. And it is for someone that wants to, say, this is great, but you know what? I like my setups. I just want to do my setups. So what we do with this technology is we 3D print a base. All of our bases currently made at Roe, our process bases, are 3D printed. They fit more accurately than the ones we were doing before. Our custom trays are all 3D printed. We print the base, we print the teeth with the glued into the base also, and have a small gap in between that we wax together. So we go from bite rims, we have the printed base, and then we have the printed prosthetic and the teeth. At that point, we do a try-in appointment of these two pieces, and you can do this with attachment cases, you can do it with the regular cases, it doesn't matter. If some changes need made, the doctor can take a bite registration and have us move it, or they can simply heat this area up with a knife or a Bunsen burner, separate it, and move the teeth into position. It used to be that a lot of the denture setups, you were moving teeth, twisting cuspids, maybe moving a midline, or doing something aesthetically in the patient's smile. Because we have the picture and we're doing such a better job of positioning the teeth within the patient's face, we found that most of the adjustments, if there are any, are slight occlusal adjustments, just tightening up the occlusion a little bit on one side, or adjusting it just slightly. So in this situation, if say this side was a little bit out of occlusion, you could loosen this up, push this into occlusion, seal the wax back up, or use impression material to seal the wax back up, and lock that into place, and then send back to us to finish. The teeth, the acrylic would not change, the base would not change, we're just changing the middle part. So floating teeth technology, if you want to set up, we can do that. There's no demarcation line between it, so you can see this is still the wax at this point, but we're just allowing you to adjust it slightly. If you wanted to have all the teeth adjusted and be able to move teeth by teeth, we can do that as well. But when it's finished, there's no demarcation line between the two, and it becomes a great prosthetic. So let's talk a little bit about denture duplication. This has become super easy in the last 8 months due to some changes with the 3Shape software. So at this point, to do denture duplication, we can give you an exact duplicate by just having the patient drop off a denture, sending it over to it and say, make me another one. So in most cases, we'd assume that the patient, you want to reline the case because you want to make sure that it fits as good as possible, and it's usually an older prosthetic, you want to tighten it up. So take a reline of the denture, send it over to us, we will scan it. You can send the opposing, it'll help us be better, we'll have more information, but frankly, we don't need it. If the patient just drops off the denture, we can do this without having a denture, opposing model to the denture. Send it over to us, we scan it, we push some specific buttons that we want in the software, said this is a copy denture, and the software automatically duplicates exactly what was there and gives us an exact duplication. And try as we might in years past, we would, trying to get the position, we had to find the right mold. Are these teeth even available? But they aren't available because they've been worn down, particularly to this patient's occlusion. There's no way we're going to be able to adjust a denture tooth to be exact duplicate of it. Well, now with this technology, we can really duplicate a denture exactly. So it's something really cool that we're doing, that if somebody wants to do, we do it very inexpensively, and you can get this exact duplication done. Or even if they just, hey, I'm afraid of losing my denture, and you didn't think of doing a duplicate denture at the time and you want to do it after the fact, we can do it after the fact. And then we also have this digital file. We keep this on record moving forward, so that if they ever want it again, we just reprint it. So as you can see, some of these little nuances of how we can duplicate these dentures, it's amazing how close it does a good job of it. So that's one technique. It couldn't be easier. So we've also been, due to our extensive experience with guided surgery and surgical guides, we've also been doing some digital dentures from a CT scan, which is a really neat technique and technology. And you can do this too if you have a CT in your corner, in your office. So first, take a CT scan of the upper and lower dentures in occlusion. Basically, put them together, put them on your chin plate of your scanner. The foam from a Robox works really well, or a piece of styrofoam works well. And you can put it on there and scan the dentures. We would adjust the density of the scan threshold to achieve adequate surface volume. So when we get that scan in, we're going to tweak the density of it back and forth to try to get this as accurate as we can. And at that point, once we convert the density and get it as clear as we can, we take that cone beam data and we use some tech software we have to turn it into an STL file, as you see here now. So at that point, we bring it into the design software and we recreate digital upper and lower tissue models. So we go back to this one, we take the integral surface of these prosthetics, basically through software technology, we create a negative surface of this and create the models. So now we have the models, we have the bite, and we have the position of the teeth. So we digital align the upper and lower models according to the existing bite. So we register the models then with these. So here we go, now we have the bite. We have the models and the bite. And at that point, we import it into our denture software and do the design of the denture matching the position of the teeth that were there before. As you see here, these are from a CT scan. We created these from the integral surface of the denture and created these dentures. As you can see, the occlusion right into the opposing denture, just like that. So, this doctor sent us this stuff, and he's like amazed at how this fit right in the patient's mouth. He wanted a duplicate denture, and without any effort whatsoever, other than scanning. So it is possible to take a Trios or a Carestream in your hand and scan a denture and give us that same information to duplicate the denture. It's not quite as easy as a CT scan. It is technique sensitive. So I would encourage you, instead of spending all the time we have talking about that, if you want to Google cupcake technique or duplicate dentures cupcake technique, there's some great videos out there of how to do this as well. I think even Dr. McMillan Cooper has one as well. But that's a great way to do it. You basically follow a scanning protocol and it's about going back and forth on how to get on there and scan it. But it is possible to do. It's a little technique sensitive and it might take a little bit of practice, but once you get it down, you or any member of your staff could do it. So one question would be, okay, this is all great, but I have a digital intraoral scanner. I want to use it for my digital impressions. So this is one of the last frontiers for digital impressions. I think the two last frontiers are for digital scanning, IOS scanning, are full arch implant restorations, creating a full arch implant case that is passive from a scan, and also doing full arch edentulous scanning. Both are possible. Both take an experienced users and some practice and some study, but both can be done. We have customers doing both. I'm lucky to have met Dr. Russo on several occasions, being on several groups with 3Shape and their KOL groups. So I've met him on some denture forums with them, and he has a nice technique. I can send you this. It's on my desktop if you want, on how to scan edentulous. He basically has a technique for how to go around the arch. If you'd like to have this, let me know, and I'll email this over to you. But this would give you a nice start on it. I think he is probably the foremost expert of doing this and scanned thousands of cases, edentulous, with successful cases. So let's review what we talked about today. Digital dentures are here. They're here to stay. I believe this is the way of the future. So there's two different processes. One is take great impressions, spend a lot of time at the bite rim, give us a photo of the bite rim in place, markings on the bite rim, tell us where we need to put those teeth, where we need to put the midline, what looks good to you, and we send you a final denture back. If for some reason that doesn't work and you're not happy with it, send it back for a very small $49 fee. These dentures are significantly discounted because the workflow is easier and the materials are easier and the setup time is easier. So even with a reverse reset, this comes in less expensive than our regular dentures. If something is wrong, we completely go back in the setup, adjust it, modify it, and send you another finished denture back. Appointment 2, or digital workflow 2, is give us the bite rims again, then we give you a setup back, a floating setup with teeth in place and the base, and we cure the material in between. If you need to move the teeth around, you just break the seal of the wax from the base and adjust it. A third option, which I don't have listed here, we could give you a fully printed try-in, but to us that seems like this is a better way to go and less room for error. So again, digital denture pricing. Standard denture, which I recommend only for economy cases where there's a definite price restriction, or immediate cases that are going to be replaced with a new prosthetic. I would not use it for immediate cases that you just need to reline and the patient's going to keep the case. If you're going to make a new denture after the fact, then I would do that. And and that calls into question a lot with immediates. Immediates, a lot of times doctors did immediates because they didn't think they would be able to get the teeth in the right position the first time with an immediate. Well, with this technology, I think we can get the teeth in the right position. So you might want to rethink immediates of being, hey, let's do a nice denture the first time, a premium setup the first time, and then we'll just do a reline as the tissue heals if the amount of teeth extraction is not that significant, where the reline is going to be a massive change to the arch. Like I said, we can do a reverse reset if we need to adjust the teeth, or if you want to set up, we do floating try-in. So I think digital dentures is a right choice now for your patients. I think it can allow you to provide a denture perhaps at a better fee for your patients. I think we can do dentures faster for your patients. And I think we're getting teeth in a position more consistently than we ever can, regardless of who's behind the mouse and who's doing the setup. But it's not just my opinion. We've done these with lots of dentures. Love digital dentures, very aesthetic. Fit is great. This doctor used to spend a bunch of time and hardly had any resets, but would still do setups. So she loves it. The fact that, hey, I don't have to do setups anymore. This is great. This doctor, oh my God, they came out beautiful with great retention. I do feel the retention is better. In fact, I believe that we are still putting post dams in our dentures, but I believe that in the coming year, we might really consider not doing post-dams anymore. I mean, post-dams were created to take the poor fit of a denture and the processing error of a denture and to create suction in the denture because of the inaccuracies of the process. This process is so much more accurate that at some point, ourselves and even the whole dental community and lab community and dentist community might consider not having the post-dam because we might get better fits with just a pure seal around the entire prosthetic as opposed to a post-dam. But we have lots of great comments on these, way more comments than bad comments. We really haven't had any. The workflow is definitely simpler and easier. So I would invite you, we have a few minutes left. If you have any questions, I'm happy to answer your questions and read them off. And can you do a chairside soft reline with digital dentures? Yes, you can. It depends on the material properties are very similar to acrylic, although it's not acrylic. It would probably depend on what material you're using, and we'd want to look at see what material that is. So give us a call, tell us what material we're using. We can make sure we have the right technique. It might involve just kind of gently roughening the surface of the acrylic slightly. So we definitely can do a hard reline on the procedure on these cases. We can also do repairs. Question about, can we make night guards out of carbon? If yes, would you say it would last much longer period? Well, we can make, sure, we can make night guards out of material. It would be a tooth colored material that we can do. We are moving to digital printed night guards as well. We have two options right now. Kulzer makes a great printed material that we're using. It has a slightly green tint to it. There's also a material from Keystone Industry that we're using, which seems to be the material to go to for splints as well. That has some really good information behind it. So those are the two that we have that we're working with. But we can make them, but they're not going to be clear because they don't have a clear material. So there's a question about inner arch space. There is no difference in inner arch space. In fact, I would be more comfortable if you have a case with minimum interocclusal distance. I would be more comfortable with less space on a 3D printed denture than I would a conventional denture. And the reason is twofold. One, these 3D printed teeth that Dentsply have are very unique. The whole lingual and the top, the underneath of the denture is already contoured away. Because the first thing, if any of you have ever set up denture teeth before, first thing you would do when you're going to set a denture teeth, to pick up your handpiece, start grinding the underneath of the teeth. I mean, heck, technicians would do that without even looking at the case. Would start grinding the underneath of the case because they all needed adjusted. That material is already gone. So it's already kind of designed with a scallop underneath it. And then if we end up printing the teeth out of their material, it's one piece. So even if there isn't a lot of room holding it underneath, it's held in a large section. So I think it would be stronger. So the question about duplicating a denture that is implant or support implant retained. So if it's like a locator denture, we can duplicate the denture. We'd make sites, where those would be, but you'd have to pick up the locators individually. So, some of these, there's a couple questions on here, and thank you for all the questions. We can use digital dentures for like bars and things like that with titanium bars reinforced, but we can't 3D print around an object. So we can't put a model in our printer and screw it down with screws on the model and print around the bar. That technology is not available anywhere in the world right now. It's all coming from nothing. Printing takes nothing and makes it something. Milling takes something away and makes it takes away and makes something. So, but what we can do is we could do a digital denture and we would mill that. So we would basically mill it around the bar, pure one-piece prosthetic, and the milling material looks very nice. It's incisal, body, cervical gradation of acrylic in the bar, and then we would basically backfill the bar. So we can do it, but it wouldn't be with 3D printing technology. That's one that we would mill and had a lot of success with that. So I have a question. Do you have an existing set of dentures for a patient in order to do a CBCT impression, or can you do a set of dentures with the CBT scan alone? So the duplicate technique I mentioned was to having an existing set of dentures. If you did a bite rim in the patient's mouth, but you'd have to have a bite rim accurately fitting the intaglio surface, not just like a triad that doesn't fit. So to answer, Dr. Hulsman's question, we can do that, but I would think you'd want to have a process-based bite rim done with the bite rim contoured, and it would give us the same sort of information as the technique that I showed with the CBCT of 2 existing dentures. The price per arch that I mentioned, we're per set. So as you know, for the economy, it's $149. For the premium materials, which we recommend for final restoration, $249 per arch. Intraoral scanner recommendations. Well, I mentioned 3Shape a lot in the lecture. I recommend 3Shape. I'm a big advocate of them. We've had a lot of people going on to the Medit scanner lately. That's a nice scanner. They have a nice program, no reoccurring fees. CareStream scanner has been doing a good job, no recurring fees with that. So most of them out there are working pretty good. If you get one that you haven't really heard of before, I'm happy to look at it. But we work with every scanner, company on the market right now, and have a lot of good success. Stay away from a couple out there that I want to say anything negative, but most of the name brand ones are really working great. It kind of becomes your price point you want to spend, and then the technology that you want to take advantage of. So I talked about integrating a metal framework. We can do that in a couple different ways. And absolutely, more information. We can use a Fox plane to bring this in. There's actually, great technology out there now for using 3D face scanning. So that's like the next verge of this, where we're using 3D face scanning to work with this technology to bring in a patient's full 3D face. We can do that right from your iPhone. We're trying to negotiate a lower fee down, but right now it's like an annual fee of $500 a year, but it does work and it gives us a whole nother level of information. So if someone's interested in how to take a 3D face scan, you really need to have an iPad to do it. It works with an iPhone, but for handing it to your patients, it's going to be better with an iPad, and they can scan themselves, send us that, and we bring a 3D face into the lecture, as well as the straight face. Absolutely. Somebody's asking, can we print a flipper? We have been doing that for the last couple of years. We haven't really been telling our clients. If we have intraoral spaces tight, we're worried about a flipper breaking off. We're doing a lot of our flippers this way now, and this might be a way that we do flippers. Sometimes we're printing them all in one material and then coloring it pink. So that's why they're not having a tooth hanging on by a little kind of a CQR small anchor. It's actually one piece prosthetic. Let's see. So flipper, we can do Essex. We can't do that technology right now. That's not available, but we can't do that quite yet because the clear materials aren't available for that. So again, this is my contact information. If you have any questions, it's BJ at Rowe Dental Laboratory. We are on Facebook. We have these videos will be on our YouTube channel, on LinkedIn, Instagram, Twitter. If you're on any of those social media sites, please join us. Please follow us on Instagram. We really try. Alexis, who's on listening now, does a great job of putting social media content through all the time. So I thank everybody for attending. And if anyone has any additional questions, don't hesitate to reach out to me, BJ at RoweDentalLaboratory.com. And I'm, got some time on our hands here with not too much going on with this darn virus, keeping us all away from our patients and friends and loved ones. So if anyone has any questions, I'll be around the rest of the week to talk about it. So God bless. Hope everyone stays healthy, and thank you for your time.